Okay, I think we'll go ahead and get rolling here, everybody. We're just a little bit after the top of the hour. So thanks for joining in. First shop talk of 2022. In talking to Joe and everybody about this, it felt like this was something that was really successful last year that we wanted to keep going. So, we'll keep some cadence of these going throughout the year. It will alternate just like last year between astrophotography and visual observing. Don't know if we'll do them monthly, but we'll certainly try to do them reasonably frequently. So this is the first installment of 2022. And we have Matt to kick us off. I think everybody recalls the format on these. Matt will do just a brief presentation, kind of get us spun up on a topic, and then we'll segue over into open discussion. And often those discussions follow up from the presentation, but we don't have to be limited to that. And as a reminder, no bad questions. Everything's on the table, and these tend to be great opportunities for everybody to learn. So I'll stop at that point, and Matt, turn it over to you, and feel free to share your screen, and then we'll take it from there.
All right, thank you, Wyatt. I'll leave it on my camera just for a minute. I wanted to thank everyone for letting me talk. Good to be back on these. Just wanted to introduce myself real quick. Matt Paige. I've only been in the society for maybe a little less than 6 months now. I actually moved to New Hampshire in August of last year, up from Oklahoma. So I was in the Army for the last 8 years, got out last summer, and then got a job in Keene. So I live in Keene, New Hampshire, working at Corning, which a lot of people might know for making glass or, cell phone screens. But the plan here in Keene, we actually make telescopes. So we diamond turn aluminum mirrors, and we have a couple instruments on the James Webb Space Telescope helping actually do the collimation of those mirrors, and then a lot of other military and commercial applications, mostly telescopes that are in space looking back down, not necessarily looking out into the stars. But it was kind of cool to get integrated in that and see what there's a lot of high tech manufacturing going on in this state. So it's fun to be a part of that. And I've really enjoyed being integrated into the society so far. Haven't gotten to get out and meet a lot of people given the circumstances, but looking forward to hopefully doing that over some events in the next year. From a personal standpoint, I'm married, have a lovely wife who helped get me into this hobby by buying me my first telescope, and I got a 15-month daughter who's sound asleep right now, and hopefully will stay that way and keep quiet for it. But so on that note, I'm going to share my screen here and grab some slides up. So hopefully everyone can see that here. I wanted to do a little talk about a program, a processing program today called Astro Pixel Processor. I think, following some of the email threads that have been going around, it's great to see that there's such a wide variety of experience in astrophotography in the Astronomy Society here. Beginners, intermediate, and obviously some very advanced people that have been doing this for a long time. I think I'm falling more in maybe the intermediate level, beginner level, somewhere on that spectrum there. But I've been doing this, trying to take pictures of the night sky since late 2020. So it's been almost a year and a half now, and it's been a really big learning curve, as anyone who does astrophotography can attest to. Most of my imaging I've done using my little Astrotech refractor there. I have a little ZWO one-shot color camera here with a screw that's coming loose that I need to fix. And I've graduated from small star trackers to larger equatorial mounts. But the processing was the one thing that took me a while to sort of get the hang of. And I think a lot of people that are new in this hobby, if you're trying to learn this from like internet research or YouTube, there's sort of a predictable path that you take of using, some, programs, some beginner programs that have been around for a while. A lot of people have heard of Deep Sky Stacker, the free program that lets you stack images. And a lot of people use Photoshop to process images, I think, because, we might have some background in regular photography. You might already have, a hand in the Adobe suite and be comfortable with those products. On the advanced end, there's, Pix and Sight, I think, is the standard that, advanced imagers, you go on AstroBin and look at image of the day. Like Lynn's the other week, pretty much everyone has been processing Pix and Sight. I think that's the, the advanced standard there. I started out using Photoshop to process images, and it was really hard. I think that program is not necessarily designed for astrophotography, and you sort of have to bend it to your will. And you can do a lot with that program, but it's tough to learn on because there's just so much that's capable of. Eventually, I found my way to this program, Astro Processor, and I want to show kind of a quick walkthrough through that today because I think it is a lot easier to use and it gives you great results out of the box. So I'm going to switch over here, switch over to a screen that shows Astro Processor. So I'm going to pause here. Does anyone have any questions or comments on starting astrophotography? And I don't know, any comments there? I know there's a lot of experience here. No, I can.
Matt, did you try? Did you try PixInsight?
No, Lynn. I'll be honest. I'm a little intimidated by it, but I think that might be something I try to move into.
We have a Slack group now for 3 of us have joined, and we talk about PixInsight, and if we have a problem, we can hash it back and forth. So just so you know, we're there for you.
Yeah,
okay.
No, that is great. I know. I remember Richard saying that he was getting some help there. So that is the awesome part about being in a group like this. I wasn't in my previous location, and learning this through YouTube is not as easy as talking to people that have had the experience. But the thing about this program is it's kind of straightforward, and it doesn't have all the capabilities of PixInsight or Photoshop, but it walks you through the right processing workflow, at least at a basic level, and it gives you really good results with minimal effort, which for me sort of was a relief because I felt like I was taking these pictures, spending time outside, and then spending hours on Photoshop to not get something I was happy with. And when I started using this program, it was sort of a couple clicks and you get something that looks good. And then as you get more experience, you can do more with it. One note, this is a paid program, so it's I think you can pay like $70 for a year to rent it, or $190. I think it is to own it outright. Some people have issues paying for processing software. I think we spend as much time on this, if not more, compared to what we actually do imaging. And people spend a lot of money on telescopes and mounts and cameras. So I never saw the issue with paying a couple $100 for a piece of software if it does what you need. And so what this does is, just talk through the desktop here. So on the left, you have basically a workflow. So everywhere from loading your your frames.
Matt, we're seeing your PowerPoint presentation, not the app.
Oh, let me. Okay, I think I need to switch windows here. And, okay, you see the app now?
Yeah, that looks good.
Okay, so walking through a little bit what this looks like. So on the left, you have a spot to load your frames, calibration frames, light frames. A lot of this will look familiar to people. And then these little windows here, you have a workflow. And this was the thing that really grabbed me as a beginner, was it takes me, 0, 1, 2, 3, 4, 5, 6, 7, and then you got these tools. Well, no 7. It ends at 6, and then you got tools, which is processing that we'll get to later. But it makes it easy to follow. And that was something that I think I struggled with in Photoshop, was not having that, step-by-step, method. You'll have an image loader or an image viewer in the middle, which I'll pull something up in a second. And then on the right, you have some processing tools that you can work with once you've actually got an image. So I wanted to do I don't know if I can switch. Let me see here. Let's switch back and forth on slides here. So I want to talk first through how you can stack and integrate a set of light frames and calibration frames in Astro Processor, and some of the benefits that I think this has over a program like Deep Sky Stacker. And I've actually, I've seen people who use PixInsight for processing, but will stack their frames in Astro Processor. Is the slideshow being shared right now?
Yes, looks good.
Thank you. Okay, so this might look pretty straightforward for people who are familiar with stacking. So the theory, in general, is you take a set of images, you stack them together to improve the signal to noise ratio, the signal being, what your camera is picking up from the night sky, and the noise being anything from sky glow to electronic noise from your camera. So there are some things that stacking can do. I guess there's a lot of things it can do to make your images better, and Astro Pixel Processor, I think, makes it pretty easy and really effortless to get the best out of your images. So, and a quick thing, what we're going to do, we're going to look at our images. We're going to register them, which is, matching the frames up to one another. We're going to normalize them, which means correcting the background for differences in lighting or different gradients in the background. And then we're actually going to integrate them. And there's some tools mentioned here that I'm going to show that can allow Astro Pixel Processor to really get the best out of a wide variety of data sets. So if I can go back to the app, and really I'll go through these numbers real quick and show you, show you what this can do. So you start off, as you might think, on tab 0 here. So I'm back in the app. And there's only 2 things you have to set in tab 0. And one thing I'll say is if you hover over anything here, it's really nice. It has these tooltips that come up, which if you want to know detail, this gives you all the detail you would need about different options in these drop-down menu. I think I watched one tutorial video on the website, where you buy this program, and that was all I really needed to get through the basics of this in 10 or 20 minutes. So you come in, you start with setting your Bayer pattern. If it's color, if it's not a color camera, if it's a mono camera, you don't have to worry about that. And then you set an algorithm, and you don't have to go in and do this. APP always defaults to sort of the standard option, something that's going to work well. But if you go into the drop downs, there are some really cool things you can do. So for example, if you're using different filters, you can set the stacking algorithm to recognize the filter that you're using. And for anyone that's using a color camera, I like to use some of the new filters that have come out that, they dual narrowband, so things that capture HA and O3. You can set APP to recognize that and basically treat your camera as a mono camera and extract, the different data from the different channels, which is something that these guys Stacker or some of the free programs just can't do. But even if you don't go in and touch this, it's gonna, APP is gonna select the best option for your data by default. You come in here, you load your frames. Pretty straightforward here. You could you set your directory and you just pick whatever you want to do. This is a folder I have set for some data I did on M33. One thing I do want to show, if I had the master flat for this thing. So if you click on anything, it'll show in the image viewer. With a lot of color cameras, it'll show green because the Bayer filter has twice as many green pixels as red and blue. You come over here and click Neutralize Background, and it gets you to a normal looking image. So this is a flat frame for my ZWO camera. And one thing I like about this is it shows all the dust spots. And I know that I have to maybe try to blow some air into my sensor and clean it a little bit. But then you can load all your other frames and you're ready to go. And the rest of the steps are, I guess the best way to say is you don't really even need to do anything. This just shows you what's happening. So calibration is the next step. And this is where APP will apply flat frames, dark frames, bias, and dark flat. It'll create a bad pixel map and take care of any hot pixels. It does that automatically. Analyze stars is just counting the stars in your image, which will be used to register the pictures against one another. You don't need to set anything there. And then we get to registration, which is the first, I would say, really tab that you might want to actually change some things in. And I'll always emphasize that you can go to integrate here, the last step in stacking, come down to the bottom, hit integrate. You could do that off the bat, and it will pick defaults that work. And it wasn't really until later where I decided to go and see what some of the other capabilities are of this program. One thing I do want to point out in the registration tab here, there is a nice little feature. It has a dynamic distortion correction. So if you're using a camera lens, especially wide angle lenses, APP can correct the optical distortion of those lenses in the same way that like Adobe Camera Raw can apply lens corrections, which really helps. It helps me for my 135 millimeter lenses and anything wider, especially 50 and 14 millimeter wide angle stuff. There's a lot of distortion in those. Well, maybe my lenses because they're cheaper lenses, and this will correct for that and kind of flatten that field out. This can also do mosaic registrations in addition to normal. So you can have, if you're trying to do a mosaic of a larger target, Astro Pixel Processor is actually apparently really good at that. I say apparently because I've never done one. I haven't done a mosaic yet with my limited AP experience, but I have read that Astro Pixel Processor really only needs a 5 to 10% overlap in frames, and it can register mosaics that are taken with different optical systems, so different telescopes, different cameras. It can match all that up. And there's a lot of examples on the APP website of how to do that. They recently added this Comet 1-star registration, I think because of the, was it Comet Leonard, whatever the latest one was, they added this in there so you can get a separate stack for a comet and the stars if you want to have the comet looking nice in your pictures. But other than that, you don't need to come in here. If you go to integrate these frames, it's going to register and line all your frames up. Same thing with normalization. This matches tries to match the gradients in your frames, so there's less of gradient from light pollution or other sources. And you don't need to do anything. You can leave these all in default, but if you do want to go in and learn what's happening, you can hover over and check these tooltips. The last thing I want to go over for stacking is just the integrate tab. Again, you can start out by coming here and just hitting integrate and it'll do everything for you. But if you want to get more in detail, you can tell APP how many frames to use. If you think there might be a few bad frames in there, you can just set this to a lower percent. Some other things that I like to change in here, APP has this really cool tool called local normalization correction, which the tooltips do a better job of explaining it. But really, this helps you match differences in sky background if there was some sort of light pollution going on, and if that gradient changed over the course of the night, or if you're taking pictures over multiple nights. This really does a great job of smoothing that out so your final stack does not have as bad of a gradient for you to deal with. Another cool tool here, multi-band blending. I wanted to point out this is really for mosaic users or mosaic stacks. This helps you get a better blend of an overlap so that there's no stitching lines or anything like that. And the last thing that might be of interest to people, so if anyone's familiar with Drizzle integration, Drizzle is an algorithm that basically allows you to get some resolution from undersampled images. So if you're trying to image a really small galaxy or planetary nebula, this basically makes I think there's probably better ways to explain it, but it gives you a larger image that has both more resolution and more noise, and you can really dial in different aspects of how much you're trying to drizzle by. I honestly I'm not an expert enough to fully explain that, but I know that you can get really in depth with that there. So I know that was sort of a quick and dirty talk through the stacking procedures, but I go through it quickly because really all you need to do is load your frames here in tab 1, come down to integrate and click, and you end up, what I did for this image was choose all defaults. And this was, the image I came up with M33. Now this is a auto stretched image, and I will pause here because the next step that I want to go into is talking about how APP can actually process your images after stacking, and I wanted to see if there was any questions at this point.
No questions, but I really like it, Matt.
Yeah, it's I think there's always more you can do in this hobby, but for someone trying to learn, this goes through all the right steps in an easy to follow manner. And it actually was a good teaching tool for me because as I became more comfortable, I started really looking into these drop downs and trying to learn what was going on rather than I don't know, playing with sliders in Photoshop and hoping that I got something good.
Well, I like the interface compared to PixInsight. PixInsight's just a bunch of modules and it's like driving a spaceship. And this is, I just like the way, I like the workflow and I like the interface. Yeah, it's great.
Yeah, I think it's a pretty good UI, and once you get used to it, it's definitely easy to use.
Hey, Matt, so you're on a
So
Mac
once
with this, right?
nope, this is a Windows.
Oh,
This-
okay. Cool.
I don't know if it works in Mac. I'm not going to say I assume so because I don't know. But I'm using a Windows computer.
It does. There's a Mac version.
Okay, awesome.
I don't use it.
And you know,
There's one.
yeah. One other thing to note before I go forward is there's a very active, and I'm sure this is you know, this is with lots of softwares, but there's an active forum for APP. The developers go and answer questions every day. I've asked them questions and had them answered. So if if you're in this and you have trouble, it's very easy to find information. The next, I'm going to switch back to my slideshow here. So once you get your stack, you get to processing. And the cool thing about this is you can stack and process in one program rather than stacking in an app like Deep Sky Stacker and then taking it over to Photoshop or Surreal or GIMP or one of these other image processing programs. You can do everything here. And I know PixInsight can do the same, but this follows a pretty easy to go with workflow, which was really helpful for beginners. And there's sort of two steps that I'll cover: linear and nonlinear processing. So linear processing, as the slide says up here, so that is really what came out of your camera. What did your sensor capture in a raw setting? And I will go back to the app to sort of show that. When you double click on your stack, APP stretches it, and it stretches it using DDP, Digital Development Program. I forget what that stands for. But if you were to uncheck this, this is what your stacked image actually looks like. And you might see that and say, that's basically nothing, but this is what your camera sensor caught. And only the brightest stars are what show up. But in order to get anything of interest out of an Astro photo, we must stretch this to change basically the way pixels are represented in the frame and try to separate objects and stars from the sky background. So APP will do this automatically. But more importantly, this stretch is not permanently applied to the image. So I think PixInsight has I think it's called screen transfer function, which is like the stretch you do while you're processing linearly. This is basically the same thing. But what that means is you're seeing the image brightened and you can saturate it, you can add things to the image, but it's not affecting the actual data that came out of your camera sensor. What that does is it allows you to remove gradients. So that's the unevenness, like this light, where it's brighter on this side than the right side than the left. And it allows you to calibrate the colors. So as you can see, this is, the galaxy looks kind of purple. The stars aren't really the right colors. If you can do those steps, so calibrating the colors and removing the gradients on on a linear image, that basically allows you to keep accurate colors and keep a more even background sky as you continue to process the image. And that's really, I don't know if I did a great job explaining that, but it's a critical difference compared to the classic Deep Sky Stacker and Photoshop workflow, because in Photoshop, you're already dealing with a stretched image. So when you're adding curves and you're adding levels, trying to make the image brighter, and then going back and trying to mess with your colors and mess with your gradients, that image has already been sort of irrevocably altered, and it's really tough to get to a natural color balance, or I should say maybe a scientifically correct color balance, and really hard to get those gradients perfectly, evened out across the frame. So, what you're seeing here is a stretched image, but the edits that we will make are affecting the linear version, and the linear version is this, almost empty image, which is the what your camera sensor actually records without any sort of processing. So I hope I explained that well. Linear versus nonlinear is really big, and this is what Astro Pixel Processor allows you to do in this Tools tab. So once you're done with Integrate, you come over here to Tools, and there are a few different options here. Did I confuse anyone, or does anyone want a better explanation, or maybe someone has a better explanation for what I said there? I don't know if there are any questions at this point. If not, I will talk a little bit about the processing steps that APP can do, really starting with the linear steps. So
Matt,
linear
I
steps that
have
we
a
wanna do-
question.
Yep.
You mentioned that the linear stack does not show the galaxy. It's showing up on your raw images, isn't it?
So that's, I had to do some digging to learn. And the galaxy, if I go to the linear stack, it's there. It's just, it's so faint relative to the brightest stars. Now, I think what confused me is when I started out with a DSLR, right? Like a Canon Rebel, kind of entry-level DSLR. And when you take a picture, even if you're in raw mode, you can see a lot in your picture, but the camera is stretching that image. So the image that you see on like the back of a DSLR is not a linear image. It is being stretched by internal software. The raw data is being recorded, but this is what raw data actually looks like. It's almost nothing. But that is because that galaxy is just faint relative to everything else, and only the brightest stars, until we stretch, are actually showing up. So it's in there, but you have to apply some sort of curves or level stretch, to use Photoshop terms. You have to change the relative intensity of those pixels. So, you know, when I brighten this image up, the software is not doing too much to brighten up these brightest stars, but it's doing a lot to brighten up all of these pixels to get the galaxy to show, if that makes sense. And that, I hope I didn't say anything incorrect. I'm not a camera expert, and I know cameras do a lot to, you know, different sensors do different things. So there might be a better explanation there, but that's the best I can say is that something you would see on the back of DSLR has been stretched to allow you to see what the camera picked up. But when we get here, what we can do is we can correct for gradients, and we can correct the colors to the raw data while seeing the results of it, if that makes sense. So we're going to correct things in that raw black image, but APP is going to show us what that looks like once the image has been stretched. And there's really two main steps that you do out of all these things here. Well, three. So the first one you do is I usually go in and crop, and you go kind of from top to bottom. So it starts with batch rotate. Really the first one I start with is batch crop, and it brings up the image. And all you got to do is drag a box. Really what you look for here is you can see where, you know, my image is a little bit off on the edges because the frames didn't line up perfectly. You would go ahead and crop that, and you would end up with a new file. It's going to save it every time. So I'll come up to the next file that I loaded here, which has been cropped. And now those edges look a little bit cleaner. The next thing you do is really one of the most important steps. It is, I skip these: batch, add, multiply, save. Correct vignetting would be if you had bad vignetting that your flats didn't correct. I've never actually used that because it's pretty easy to take flats. But I would say the most important step here then the next one I would do after cropping is this remove light pollution. And what this does is it's going to fix the gradients again, it's going to do that on the linear stack. It's going to fix the gradients, and it's going to also calibrate the background. And this is critical to getting a sort of even looking sky, and it's critical to getting a good color balance. And it's almost like magic when I first started doing this, to how good this is at removing light pollution. I want to real quick show, if I can go here. Oh, my screen froze up. So, can everyone still see me? My mouse moving around?
Yep, I can still see it.
Okay. Yeah, I was trying to share back to the slides, and that froze up Zoom. So I'll stick with APP here. But I want to show how good this is at removing light pollution. So I'll go over to this stretch. I'm going to just basically make this image brighter to exaggerate how, and I do want to talk about this side at the end, but and I'll specify what some of these things are, but I'll make the image brighter to exaggerate how bad that light pollution gradient was. And if you make it really bright, you can see that there was probably some house lights or something. You know, I imaged from my driveway. There was some light coming in on the camera there, and we need to get rid of that. And it's really easy to do that in APP. And you come into this remove light pollution tool, and you draw boxes. You draw boxes on your image, and it says, you know, kind of tells you what to do, make 5 area select boxes, and you do that by just clicking on the image and drawing a box somewhere in the background. And the only stipulation with where your boxes are is they should not be on the actual object itself. So whether that's a nebula or a galaxy, your boxes should not be on that deep sky object. They should just be on either background or stars, which APP is basically going to ignore. It's just going to look at the background. And if you went in and drew a bunch of boxes and click calculate, APP is going to do its thing, and it's going to even out that image. And that was, you know, really without any thought, just putting some boxes around. But if I was taking, you know, if I wanted to take just a few minutes, you could really just put boxes all over this image and make sure you got an even sky background, which is what I see now relative to where I started. Oh, sorry. If you click on this show corrected image, it shows you what APP is actually doing and how it's correcting that gradient. So that's what that is the model that the software applied, and that gets me a much more even looking sky background. I'm going to hit cancel here and then go to that cropped stack that I had. So here's where we started. And after we did that tool, what you would end up with is a new file that says LPC, stands for light pollution correction, calibrate, or CBG, calibrate background. And this gives you a file where the background is much more even looking, the gradients are corrected, and this is going to allow us to calibrate the colors. And it's really important to do this before you apply a permanent stretch to your image, because after that point, it's almost impossible to get rid of those gradients fully. The last step here that is really important in the linear processing step is calibrating the colors. And so that's what I'll go over next, because right now we have a galaxy that looks kind of funky. Shouldn't be all purple. And we got some stars that don't really look like natural star colors. And APP can correct that pretty easily using this Calibrate Star Colors tool. And I had a little slide that showed what this was doing, but this is, I can't get to the slideshow right now. My computer's being a little funky, but this tool is interesting because it uses star color physics to figure out what the colors in your image should be. And notice that it says over here, adaptive black body and extinction. So I'm sure there are people on the audience now that have a more scientific background than myself and can explain black bodies better than what I can. But basically, APP is going to look at this image and try to match star colors to what it expects, you know, the average subset of stars in the Milky Way to look like. And, you know, some of you might have seen the color diagrams that show, you know, the distribution of red, yellow, blue, white, you know, the different types of stars that we have in the galaxy and in what sort of proportion those are. That's what APP is doing when it tries to calibrate the colors. But as far as what the user has to do, just like in the previous window, all we have to do is draw boxes. And it says, you know, only draw one box. I usually just try to draw a few that go everywhere on my image except for the actual object itself. I don't want that in the box, just stars. You hit calculate, and APP is going to look at all those stars and try to nudge the colors so that those match what, you know, what they actually would be based on the, you know, distribution of stars in the galaxy: blue stars, yellow stars, red stars. This is what I get. So to me, already, this looks a lot better initially. The galaxy looks a little bluer. The core looks a little yellower. We've lost that purple. This does have a green tint to it, I would say. That's kind of characteristic of color cameras, just having that extra, well, the Bayer pattern, 2 green pixels for every 1 red and blue. But APP can correct that pretty easily as well. This still just looks a lot better than what we started with. And then on the left, it shows you sort of the color diagram, how it's matching blue, green, and red. Again, it's one of those things that I started looking more into the more comfortable I got with the program. But in order to just get better colors, all I had to do was click on the screen and drag boxes around. And that gives me an image that already looks a lot better without really any effort at all. So we went from our...
Lost your screen. We lost your screen.
Oh, okay. No, I'm getting... I'm trying to fix here. Now my Zoom bar is giving me that little spinning circle. Anything, or is it still frozen there? I don't think it's
Nothing
still
yet.
fully frozen. Let me... One last try. No. I'm a little bit at a loss here. My screen, I keep clicking on the share button, and I think I might have to maybe drop out of the meeting and come back in a second.
Hey, Matt, have you tried turning off your camera just to reduce the load there?
Yeah, let me do that. Not even clicking on, click on camera. Oh, well, that might work there. Good idea. Okay. Is that back?
Still nothing.
Oh, it kicked me out of the meeting, so I think I just need to log back in. I'm on my phone on audio.
Oh yeah, that's right. We still got your audio. Yeah, so okay, that's cool.
Yeah. So I'll pop in. Sorry for that inconvenience there. That was, I think I had a little too many windows. So
And
just logging back in here.
Your new session is trying to connect you to audio, so be sure you disconnect computer audio on the new session and keep your call in only.
Yeah, I think it's got me. Let me get back to sharing. And how does that look?
Looks like you're back.
All right. A couple minutes of delay there, and I know it's a nice clear night out, so I don't want to take too much more time. But what we did, we went from this gradient corrected frame, and we drew a couple boxes on the screen, and that got us from these colors here to a much more natural, I think, color looking image. And honestly, for me, in my first year plus of astrophotography, like I would be good with this right here. I would save this image and show it to my friends and family and be pretty stoked. And I think this would have taken me a lot more effort to get out of Photoshop. I'm starting to get to the point where I expect a little bit more. So I try to do a few more things, and I want to show some of the other tools that APP has. It has a selective color tool, which if you go in there, it allows you to very, very selectively alter the colors, and you can do RGB, red, green, and blue. You can alter cyan, magenta, and yellow. You can see that there, and you can also go in and really choose what part of the dynamic range you want to target. So some applications here that APP can do, you can select 0 to background and all of your colors, and this would allow you to remove chromatic noise from your background. So if you zoom in, all those weird looking splotchy colored pixels, you could target the highest percentage of your dynamic range if you wanted to deal with the star colors, and you could target the mid-range if you wanted to work with other parts of the galaxy. So I'm still sort of learning my way around that tool, but I know when I processed this image, I was able to get from this initial color calibrated image, and I was able to turn that into this, which just looked a little different for me. The background looked a little cleaner. The blues and reds separated a little bit more. You can see some of the nebulous areas in the background. So again, I haven't really done much with that tool yet. I'm still sort of learning it. But even before then, that's an image that I would have been pretty happy with almost no effort processing. Last box down here that I'll show is the star reducer tool, which actually just came out in the latest version of APP. And it's a really good star reduction tool. It's not that complicated. It just makes your stars smaller, kind of the way a minimum filter would in Photoshop. And it does a very good job at that. So if you're stretching your image and you want to make your star smaller, you can bring it into APP and it will do that. So a lot to say there, but really the most important things that we did out of all of these windows is we've removed light pollution and we calibrated star colors on our linear data. So that gave us an even looking image and a more natural color balance that you could take from this and either be done with it, or you could take it into another program and keep processing it. If you look on the right here, there are a few more options that you have to sort of finalize your image. So I'll go over that quickly. And this question mark is a tooltip, and it'll explain what all these things are. I don't want to risk, messing up my screen again, so I won't click on that. But from top to bottom here, you have a black point, a white point, and a gamma. That that allows you to adjust sort of like a levels would in Photoshop. This drop-down menu is really the crux of this whole thing, and this is just how intense the stretch is. So farther, 10%, something like this is going to be not as bright, targeting the background at 10%. But if you scroll all the way down and you get a really strong stretch, then it's going to look kind of funky, a little blown out. So you can go somewhere in the middle and pick, pick something that gives you a value you like. And, that looks like a pretty cool M33 to me, something with minimal effort. Further down, you can affect the highlights. You can protect those stars from getting blown out. You can add saturation. You can add contrast. You can sharpen. And then this protect thing has to do with protecting the stars from looking weird when you sharpen. I breeze over those final fields because, what I'm trying to emphasize is just how easy it is, in my mind, to get a decent looking image or really a good looking image from Astro Pixel Processor with minimal effort, which was what I wanted in my first year of astro photography, when I was trying to just learn how to set everything up, polar align, and take pictures. I didn't want to get in the computer and not be able to turn that effort into something worth showing to people. And that was really the turning point that made me want to buy this program and tell people about it, because I think a lot of people struggle through Photoshop and then eventually learn how to use PixInsight. And I think this is just another option where until you're ready to take a little bit more of a plunge into a more intense program, this can get you great results, quote unquote, out of the box, where all you have to do is load frames, click integrate, and then draw a couple boxes on your screen with these tools, and it gives you something good. The last thing I wanted to go through before I open it up to questions, I'll come to my slides here. Just a little bit of my thoughts on pros and cons of this program. And I'm not going to go into the presenter mode because that's what froze my screen last time. But pros and cons, I think I've hit a lot of these on the left side with our smiley face here. We have an easy to follow workflow that encourages the proper steps. And I say proper with, doing things in the right order, as opposed to Photoshop, where you can kind of free form it and not necessarily know if you're doing things in a correct workflow. Repeatability, it's easy to get the same types of results because there's not that many things to manipulate. The defaults are going to give you good results. And it's really easy to go online and look in the forums if you need help on something. There are some cons to this though, so this isn't a perfect astrophotography solution. There are some capabilities that this just doesn't have. So, this can't do deconvolution, which I know PixInsight can, and there are other programs you can do to try to get some resolution back there. This can't do noise reduction. So if you wanted to do noise reduction, you would need to take this into it's a Lightroom or Photoshop or Topaz, whatever suite you want to denoise in. It does take a fairly long time to do integrations, longer than Deep Sky Stacker, which is the only other app that I've used, even if I think it gives better results than that. And one thing that I do want to emphasize, so it's limited in how you can stretch your data and the control you have over stretching. And I wanted to show an example of that. So this picture was, M33, it's a single object in the center of the frame. I think that's what APP does really well. I want to pull up another image where I thought APP didn't really allow me to do everything I wanted, which is this image of the Pleiades or M45. Are you guys seeing the app right now?
Yes.
Yeah.
Okay, so this was an image of the Pleiades. This is unprocessed, just stacked. And when I took this, I really wanted to try to bring out some of the dust that was around the image, this really faint integrated flux nebula. And in Astro Pixel Processor, the only way to really do that is to try to just make a stronger stretch. And if I do that on an image like this, I might start to see more of that dust, but there's no way to do that without sort of protecting the rest of your image. If I really exaggerate the stretch there, like, okay, I can see some dust, but now my star cluster looks weird, my stars look weird. That's not good. So an image like this is something that I would stack in Astro Pixel Processor. And I found myself using Photoshop to process this in order to get something that, presented the dust, nicely with a balanced star cluster that wasn't blown out. I found that I was not able to achieve that effect in Astro Pixel Processor just because of the limited control you have in how you stretch the image. It's just, there's not much, it's not like the curves tool where you can really target different parts of the dynamic range in a different manner.
So what do you mean by stretch? What do you really mean by that?
So stretching is, and again, so yeah, that is a fundamental term for astrophotography, and that has to do with that linear versus nonlinear image. So if we go linear, like we were talking about earlier, an image that looks almost blank, and I think a better way maybe to describe this is if you think of your camera sensor as made up of pixels, and those pixels are receiving photons from somewhere, the linear image just shows a representation of how many photons those pixels received, whether it received photons from the background sky or stars. That's what this is trying to portray. But what we do when we quote unquote stretch an image is we try to exaggerate that sort of relationship of what pixels received what number of photons, which means I want this Pleiades star cluster to really be a lot brighter than the other stars around it. I want the nebulosity there, even though that's really not that much brighter than the background sky. I want that to pop, so it looks like it is significantly brighter than the background style or the background sky. And that is what a stretch does. So we're boosting pixel intensity locally, I guess would be a way to describe it. So there's nebulosity in the star cluster, and I'm boosting the intensity of that without boosting the intensity of the background or just the dark sky. And I make it sound like it's really complicated, but that's all what the software does. So that's what these numbers here, that's what that's doing, is it's boosting these this blue wispy nebulosity a lot more than it's boosting just dark sky around here. And same goes for stars and for the dust that surrounds this. So that's what stretching is it's changing pixel intensity, from one point of the image relative to another. Does that sort of make sense, Wyatt? And maybe not, because I don't necessarily fully understand exactly what
Yeah,
the software is
that,
doing.
that helps me. Thank you very much.
But that is, if you're in Photoshop, for anyone who uses that and you're using the curves tool or the levels tool, that's what you're doing. You're stretching the image. You're trying to make things almost unrealistic in the differences in brightness, because this dust is really, astronomically, it might not be distinguishable from the background sky at all, but I'm making it seem like it's very distinct, just like I'm making it seem like this nebulosity is very distinct from the background sky. When if you look at the Pleiades in a telescope, and this is not necessarily what you would see unless you were in a very, very dark site, which I haven't really had the pleasure to observe from. I observed from a backyard in Keene, so I just see a star cluster. Anyway, so that was this is an example of something that I didn't feel like I could process completely in Astro Pixel Processor. One other example I want to show is, and I like that. Steve, I think it was you who sent the image of the Spider and Fly Nebula. That's a similar target to what I last shot. And one really cool thing that Astro Pixel Processor can do is it can blend images taken with and without filters. So I use a color camera, and sometimes I'll image a target without a filter to get nice looking stars, and I will image a target with a narrowband filter to try to pull out nebulosity. And that's what I did with this target here. So I took a set of images without any sort of filters on my camera, and I was trying to make, this is M36 and M38, the open clusters in Auriga. And then what I wanted to do in this was get some natural looking star color, but I knew that an unfiltered image on a colored camera wasn't really going to show much of the nebulosity in this area. But what I was able to do was take another set of pictures and process them with a filter. And that shows you a whole bunch of hydrogen gas, hydrogen dust in Auriga, and around these open clusters. But what this filtered image shows is weird looking stars, right? And that's a little bit of my scope's spherical aberration. But stars aren't that color. They're not magenta and green. That doesn't make sense. But what I was able to do in Astro Pixel Processor was take those two images, load them, and register them against one another. Basically just align the stars. I was able to then remove the stars from this image. And I'm not going to go through that. This is just me talking through capability. You can remove the stars from one and add the stars from the other. And that allowed me to have an image that had the natural colored stars and the nebulosity. I don't think I still have that file here. I don't know where I put the process file, but that was just an example of a capability there where you can take a filtered image and an unfiltered image. You can register them against one another, and then try to get the best of both worlds. So natural star color and nebulosity from a narrowband filter. Something I had tried to do in Photoshop, but was much more tedious because you were trying to manually align everything. And it was really hard to do. So I'm going to pause there. That is, see if I can get my video back up without crapping this thing out. But I wanted to, at that point, pause and see if there's any questions. I hope I explained that, workflow in a way that made sense. I'm sorry if I'm pausing here. I was trying to get my camera back on.
Matt, I think you've done a great job of explaining it. And I've been using APP for about 8 months now, and I think you're probably farther along than I am, except that I use a monochrome camera and filters, which is somewhat, the processing is similar, but you have to do extra steps. What I would do to get that nebulosity in the Pleiades, which you're having trouble with, is you have the option of adding the results from your various filters or the lack of filters into the RGB and luminance channels. And what I would do is take some of the H2, which is where a lot of nebulosity lives, and I would put that in the luminance channel, and it'll really blow that nebulosity up. But I agree with you. The stretching is kind of canned how you do it, and you select a few parameters, but it does a great job for the limited number of parameters that it gives you control over. So
Yeah, it's just easy, and that's exactly right. I haven't messed around with that combined RGB tool as much, but that just goes to show you can learn more, but you can get a lot out of a lot for a little effort, which I think, you know, the amount of effort we spend to get these images, it's kind of nice to let the software do the heavy lifting for us. At least until you get more experience and then you get deeper into the program, like I think you and I are both doing now that it's been we've spent some time on it.
Yeah, my experience is similar to yours in that I started with Deep Sky Stacker and GIMP, and GIMP is pretty much like a freeware Photoshop. It's not as powerful, but it's powerful. It was really painful processing stuff doing that, and then I decided I would try both APP and PixInsight and see which I like best. And I never got out of APP. I still intend to try PixInsight. I think it's got, from what I see, gives you more control, but at the cost of a great deal more work from everything that I hear. A couple other things about APP. It uses your FITS metadata. So if you're producing FITS files, it will intelligently manage them. It will know which filters you used and allow you to to stack the filters independently. It's convenient to do that. The star calibration that you talked about earlier is really an RGB thing. It won't work if you're using narrowband filters, but it works quite well if you're using RGB, and you can use it to sort of adjust stars to look reasonably normal. The biggest disadvantage that I've found with APP is its utter lack of documentation other than what's in the tooltips. And there was actually a really big blow up about that on the forums, which I'm afraid I started because, well, there are a lot of people who are complaining about it, but in my previous life when I actually worked, I did a lot of software documentation because I was a developer, and so I offered to do some documentation for them. I said, if you'll just sort of send me some crap, I'll organize it and put it together into a reference manual. And but he didn't want, and a lot of people started getting on that bandwagon saying, yeah, we really want a reference manual. And there were a few other former software or current software developers who agreed to work on it, but he wanted to do a wiki. He didn't want to do something that was like an old-fashioned reference manual, which is where my experience lies. So it just kind of went away, which is too bad, because it actually is very powerful, more powerful than I can deal with. But you just, unless you want to go and look up the image processing literature, you don't know what all those parameters that you can modify are. There's a lot of them. So it really is a powerful program.
Yeah, and that's a good point where you get to the level where you want to get more out of program, and that's where it can get tough, and you got to do digging in the forums. I think, you know, my opinion is that APP will not be like the last program everyone uses. I think it's probably a stepping stone to get into PixInsight. At least for myself, I think that's where I see it going. But in the time where I didn't want to sit down and really learn a complex program, it just allowed me to get, I think, the most out of my data in a really easy manner without a lot of time, and it also let me learn the process. But I do think, yeah, there are some flaws, and you know, maybe they'll address those going forward, you know, to help make this more comprehensive and something that people feel like they don't have to graduate from later on.
Awesome. Any other thoughts or comments? That was a Outstanding presentation, Matt. Really, really clear. I don't know anything about AP, but I've learned a ton. That was awesome.
Yeah, if anyone, I think my hope is that if someone's starting out, they're take a look at that program, because I think it is easier than the standard Deep Sky Stacker Photoshop. You can spend hours watching YouTube videos and not really know what you're doing there. So that's my thoughts, and thanks everyone for letting me share that.
Sweet.
Thank you, Matt. It was awesome.
All right.
And I'm curious if anyone, I guess, for a discussion standpoint, I know we have PixInsight users and maybe other programs. If I don't know, how does that compare, or where would you see that fitting in your workflow at all, or do you, I'm curious what other people's thoughts are based on their processing.
The lack of, it has no masks. Is that what you said? No masking ability?
Correct. So that goes into the lack of control with stretching. You can't do, the star masks or luminosity masks that you would do in PixInsight or Photoshop.
Yeah, we spend an awful lot of time making masks.
Mm-hmm. Yeah, and that's where I really found it to just be good for single, like that M33 image where it's just one target in the middle. The middle of the frame, easy to sort of deal with.
Yeah, you don't
to
really
get more
need a mask
complicated.
for
You need
that.
that. No.
I'd like to see the star reduction program. Did I miss it? Did
I
you
can
show?
actually maybe just run through that, because that was something really cool to see. I will. So I know PixInsight, and you can use it standalone. The StarNet ++ is the program that's integrated in the PixInsight, and I use it actually as a standalone. I think that does a slightly better job, but this is pretty good. So I'll go to my M33.
Well, the StarNet ++ removes the stars.
Yeah, so that's a good point. This is I was thinking of that. This can reduce the stars.
Yeah,
and
and that's
do
It
it in a
also
pretty
makes
natural-
one of
it
the
can
best
also
star masks.
it does. It does. It makes a great star
Yeah.
mask. But reducing
I mean,
stars
star
in
fields,
Pix,
it's the stars.
Yeah,
So-
so this is something that's pretty new, and I'm still learning my way around it. From what I understand, so you can remove the stars completely. Like Steve said, the documentation is a little lax, but you have a radius and a halo slider, and then size and intensity. So I think what I've tried to do in some of the latest images I've done is and this is just me experimenting. I try to bump this radius up a little bit from standard, bump this halo up. And if you wanted to just reduce size and, intensity, I take up as the brightness of the star. If I were to take that down to say 75.
how the heck does it do it without a
this is-
star mask? It must have a star mask tool like built in.
Yeah,
behind the
it must
scenes?
build it in. But that's, I think
Yes.
the whole philosophy behind APP is just doing it easily without
Yeah.
all the fiddling. You can see the chromatic aberration of my doublet scope if I zoom in here, but and this I think takes a little while going through its process.
Is the chromatic aberration being shown because there's green on one side and red on the other on the stars? Is that what you're talking about?
I think that the blue tint on my stars, or bluish greenish tint on the yellow stars.
Yeah.
I think that's just a scope property. So that's the reducer right there. So it went from bright stars to
Oh,
smaller stars.
Well, that's
Zoomed
nice.
out was this is bright and
oh, but you lost some color.
small, so pretty. Yeah, this is again where you could be more selected, but if you wanted to do it easily, this is about as easy as it gets. I think it still makes the object stand out a little more.
Yeah, definitely. It looks good. And how do you remove the green from there? You said there was a color tool.
So yeah, what I do, well, there's the green cast overall. I do that in the selective color tool. So if I take my star color calibrated, what I do is I go into selective color. And the way that the tutorial I saw on the Astro Pixel Processor website recommended was to basically select all of your dynamic range, your green colors throughout the dynamic range, so 0 to 100, which means every level of brightness from the background to the brightest stars, and you just desaturate, minus 40%. So you do that. I've just started using for anyone who does Photoshop, so that did an okay job. But the Hasta La Vista green plugin to Photoshop does a better job, in my opinion. Now that I've gotten a little more discerning on these images and wanting to make it perfect, but this can do a pretty good job. Yeah, and I was saying the chromatic aberration, I mean like the tint on my stars. I think that's just a scope issue with having a cheap doublet.
Well, this
I love my
produces
Astro.
better images than a lot of the images I see on Astrobin.
Yeah, I think there's a lot of potential.
Yeah.
And I was able to go back and process images that I had done on Photoshop and quickly get much better results, spending a lot less time on this.
Yeah, less time and better than someone struggling with PixInsight or Photoshop and producing an inferior image. Nice.
Yeah, and I think, this almost could be like a helpful learning tool where this helps, for me at least, it helped me learn, what's happening in processing and, why am I doing stuff on a linear image versus nonlinear. It took me digging into the forums a little bit, but, that I think will maybe make PixInsight easier to figure out rather than starting that from scratch if I try to go into that, stone cold. But yeah, it's a really cool program. It costs a little bit, but it doesn't cost as much as an Adobe subscription, I guess. Although I have that too to do some final touches. Wyatt, that's all I got. I guess if there's any other business, or move on to open discussion from that point.
I think that's good. We're about 10 past the hour. So unless anybody has any other questions, I'd just say, Matt, fantastic. And I've recorded this. So Joe, I'll shoot you a link to the video so you can post it up on YouTube if you'd like, and put it out on the forums. And Matt, thanks for doing this.
Thank you, Wyatt. Thanks for having me. It's fun, Joe.
Awesome.
Thank you, Matt.
Thanks, Matt.
All right. Have a nice evening, everybody. Thanks for coming out. And we'll talk to you soon.
Thanks for hosting, Wyatt.
You bet.
Bye. Bye.
Bye.
Have a good night.